We're recording to the cloud. So where we left off last time was with this graph right here. I left you with the bit of information about this graph. We graphed this line by plugging in points. I picked either an X or a Y value, and then you figured out the other value. And so that highlighted the two skills necessary for graphing. Skill one was being able to plot an ordered pair. Okay, I'm hoping that felt pretty good to everybody. And then skill two was being able to manipulate an equation and plug in one value to get the other value out. Those are the two things we did. So now what we're going to look at in the rest of section 2.1 and then section 2.2, which is what we're going to get through today. We're going to talk about two kind of quicker or easier or hopefully less stressful, but very straightforward ways to graph. Okay, so you can always plug points into an equation and come up with the graph. So the first thing we're going to do, though, is we're going to take advantage of where we left off on our last class, which was identifying these two particular points, because these two particular points are going to help me graph quicker. And so we mentioned, or I mentioned, and you helped me, that the x-intercept, meaning where the graph goes through the x-axis, we noticed that the y value there is 0. Okay, if you're at any point on the x-axis, on this dark line that goes left and right, any point on that axis has a y value of 0. You have not gone up or down at all. A similar thing can be said about the y-intercept, where the graph goes through the y-axis. Only this time, if I'm looking with respect to the origin where I start, I haven't gone left or right at all. Okay, so any point on the y-axis, I don't go left or right to get to. So what we're going to do then is we are going to practice graphing simply using the intercepts. Okay, now that we've plotted points, now that we see that there's a relationship between our x's and y's. So here is our instruction, how we're going to do this. This is going to be my example, and then I've got a couple examples for you to do. We are going to graph this line using the intercepts. Again, the value of this is it just saves me a little bit of time, because when I'm plugging in 0, I've got less arithmetic to do. So less arithmetic means less mistakes. It means being able to be done quicker. So here's the graph. Here's the equation we're going to do. 3x minus 2y is equal to 6. We're going to graph this one. We're going to do this one together. So right next to this graph, I'm just going to make a little table like we did last time. But this time, all I'm going to do is I'm going to pick my intercepts. Now, again, you are not limited to this. You can pick any x or any y value you want to plug into an equation. So, if you don't feel comfortable just using 2 points, use more points. Okay, so we're going to use the intercepts. So the first one is the x-intercept. I'm just abbreviating here. The second one is the y-intercept, again, abbreviating. You're going to help me because I want this bit of information to sink into your brain. There we go. I can speak. To find the x-intercept, if you look back on that graph we just had, or if you've known this before, to find the x-intercept, what do I plug in? 0 for what? It's the reverse of what you think. To find the x-intercept, you plug in 0 for the y value. To find the y-intercept, you plug in 0 for the x. Exactly. There we go. And herein we'll see the value. When I go to find the x-intercept and I plug in 0 for y, what I get is 3x minus 2 times 0 equals 6. So I've plugged in 0 for y. And then this is the fun part. 2 times 0, boom, it's gone. Anything times 0 is 0. And so after you've done a couple of these, you can do these without writing hardly anything down. You can use your thumb to cover up that term. But I'm going to write all this work down because I want it to be in your notes so that when you engage your homework later today, you can remember exactly what we did. I'll divide both sides here by 3, and I get x is equal to 2. So the x value 2 goes with the y value 0. That's my x-intercept. Similarly, for the y-intercept, I'm going to plug in the x value 0. So what I get is 3 times 0 minus 2y equals 6. 3 times 0 is 0. Boom, that's gone. And I'm left with negative 2y equals 6. I divide by that negative 2. And you can see how the arithmetic just goes nice and quick and easy. On the test, I promise you this, I'm not going to give you any intercepts that are fractions. I don't want you to, have to be worried about where you're plugging things in, but it's possible you can get fractions. And if that happens, then I would just encourage you, if you're not comfortable, if you don't feel like you're going to graph the fraction well, then pick another point and figure out another point that's going to be on the graph so that you have confidence. Okay, so these 2 points, the 6 divided by negative 2 is negative 3. So there's my 2 intercepts. So here we go. The x-intercept is 2, 0. So I'm going to make a dot right there at 2, 0. The y-intercept is 0, negative 3. So I'm going to count down 3. And now I'm going to connect the dots with boldness because I'm so proud of myself. I'm going to put arrows on the end so everybody knows that that goes forever in both directions. And there is my graph of 3x minus 2y is 6. I'm going to have you do 2 of these in succession just because I want to make sure we've practiced it so that as we move on and finish up this section, I can feel super confident. Does anyone have a question about what we just did there? Yeah.
So you chose the points like what numbers to put in?
I chose the points because what I asked us to do was to graph using the intercepts. So using the intercepts tells me that what I'm going to do is I'm going to plug in 0 for y and I'm going to plug in 0 for x. That's how I know. When you use the intercepts, yes. Okay, but again, let me just reiterate because I want us to be with confidence. I'm just following the instructions. I did get a question on my math lab. I don't remember if it was in this class or my other class. Somebody had graphed something properly, but in my math lab, it said graph using the intercepts. And so then it didn't recognize the answers because whoever sent me the problem had one of the intercepts and then another point. And it was lovely work. And on the test, I would have, yes, great. But remember, my math lab's a computer. It's got limitations. So make sure you're following the instructions. Okay, so that's the key. So here is yours. I'm going to have you do 2 of these. Here's your first one. I would like you to please use the intercepts. That's what I'm going to do to graph 2x plus 4y is equal to 8. Okay, so please graph that using the intercepts. Okay, so I asked you to do this using the intercepts. So we're going to find the x-intercept by plugging in 0 for y. We're going to find the y-intercept by plugging in 0 for x. So now the rest of the problem is just a little bit of an arithmetic deal here. So when I find the x-intercept, I've got 2x plus 4 times 0 is equal to 8. 4 times 0 is 0. I love that. 2x equals 8. And when I divide by 2, I get my x value is 4. So that's going to be my x-intercept is going to be 4, 0. Similarly, I'm going to plug in 0 for the x value. So 2 times 0 plus 4y equals 8. 2 times 0, 0. So I've got 4y equals 8. Divide both sides by 4. And you can leave out some of these steps. I know they're all the same steps every time. And so there's my x-intercept, there's my y-intercept. The x-intercept is 4, 0. The y-intercept is 0, 2. There's my 2 points. And the final result is going to look like this right here. So woo, just like that. Just one more for good measure, just to make sure we're repeating and learning. So if you have any questions about this process, please feel free to chime in. Can I move the page? Everybody good? All right, here's the other one I would like you to do, please. I would like you to do negative 3x plus 8y is equal to 24. I'm going to get started on the work here. So if you're still cooking through this, that's totally great. I'm going to start with my x-intercept. I'm plugging in y as 0. So I've got negative 3x plus 8 times 0 is equal to 24. 8 times 0, 0. And so when I finish up this work and divide by the negative 3, I get the x values negative 8. So my negative 8 and 0. Then I plug in the x value 0. So negative 3 times 0 plus 8y is equal to 24. 8y is 24. And when I divide, I get y is 3. I'm picking relaxing numbers here so that we're not spending all day with our calculators, things like that. Don't assume any unintended patterns, because I know like this one, the x-intercept is 8 and there's an 8 in the equation. The y-intercept's 3, there's a 3 in the equation. That doesn't always happen. That's just kind of because I'm picking relaxed numbers. Okay, so always go through the process. Make sure you're doing that. There's no unintended pattern. I will never hide anything like that from you. Okay, so I always tell you the quickest and easiest way to get through some of these things. Okay, so all right, so the x-intercept is negative 8, so negative 5, 6, 7, 8 right there. The y-intercept is 0, 3, so right there. And now I connect the dots and I am just about done with the problem. So whoop, there it is. And there's my arrows and we're good. Questions, comments, concerns, anything I need to hear about? Am I not doing a good job? Please let me know. I want to do better for you if I can do better. Doing amazing. Well, I'm going to give you the student survey today so that you can fill that out while you're still feeling that way. I love it. Okay, so there's two final things I just want to talk about in this section before we move on to the next. There's a couple special situations that you might have on your lines. The first is this. Let's say we want to graph this line here. Y is equal to 3. Now here's the thing. what is different about this equation than any of the other lines that we've graphed in today or last time? There's no x variable. I'm just going to make note of that here, that what's going on is there's no x variable. Let me write an x. There we go. There's no x variable. So what does that mean? And I'm sure at some point most of you have seen this. Maybe I'm just refreshing your memory. I'm going to do a little table for this first one, but then I would encourage you, because I'm going to put one of these on the test, or maybe one of the next one, or maybe both, and I just want it to be nice and free points. So just, I would recommend remembering this. Okay, so what I'm going to do is make a little table. This equation says no matter what is my y value going to be? 3. So if I pick the x value, I'm picking these, okay? I'm generating these. You can pick any x values if you want to use different ones. If I pick the x value -2, this equation says what's the y value? 3, has to be. Okay, there's no x variable. If I pick the x value 0, what's the y value going to be? 3. Just one more time for great effect. If I pick the x value 5, what's the y value going to be? 3. Yes, there's not a whole lot of creativity in this problem. It says no matter what, the y value is 3. So I'm going to plot those points, -2 and 3, and then 0 and 3, and then finally 5 and 3. And I'm going to connect these dots. Does anyone know what this kind of line is called that goes just straight left and right like this? Yes, this is called a horizontal line. Great vocabulary. Appreciate your help. If you're like me and have trouble remembering these sort of little details, horizontal line goes left and right like the horizon. Okay, if you're looking out at a sunset. Okay, so those two words are related to each other. And so here's what you can take to the bank. Anytime you're given an equation that is y equal to a number, doesn't matter what that number is, once you see that there's no x variable, automatically you can say that's a horizontal line. And just make a horizontal line with your straight edge, and then you go wherever that value is. So if I then say, okay, I'm just on the same graph, just because I'm trying to conserve trees here. If I say, let's go ahead and graph y equals, that's hard to see, -2. So again, your mindset, you can make a table if you need to. If you're freaking out on the test and you forget, then make your little table. It's great. But if you remember, then you say, okay, there's no x variable. So it's a horizontal line. And this horizontal line that's now in orange on my page is going to be at what y value? -2. So I'm just going to go down to, you don't have to show me any other work other than just drawing the little line right there. And there it is. I'm going to label it because I'm guessing most of you don't have awesome colored pens like I do. So there it is. So just real quick to make me feel like I'm doing a good job today, one more, and you can pick a new graph. I got plenty of graph paper for you. I'm going to use the same one just with a different color. I would like you to please graph y equals 7. Okay, the repetition is just to help us build some memory. Again, there's no x variable, so that means right away you can identify it as a horizontal line, and I'm going to go up to the y value 7, so you should be up above the number 5 at 7, top half of the top part of the graph, and I'm going to again label it just because in case you use the same grid, that top one, the red one on our page, is y equals 7. Horizontal lines, all of them, because there is no x variable. So far, so good? All right, I hope so. Let me know. I'm here for you. Same thing. Let's say that I have x equal to 2. Again, many of you know what to expect. You've seen this before, but just in case you haven't, I'm going to do the same thing. But we notice on this equation, what's this equation missing? Okay, there's no y variable. Okay, I'm just going to make that note so that when you look at your notes later, you can understand why we did what we did. Okay, now this one, as opposed to the other one, this one says what? The x value has to be Yeah, so this time I can't pick any x value to plug in. I have to pick one specific x value. Does this equation say anything about the y values though? No. So my first entry, my ordered pair, my x value is 2. What's the y value? 2. Okay, somebody said 2. The next entry, the equation says the x value is 2. What's the y value? What'd you say? 0. Sure. This is a you choose. The next one, the x value is 2. What's the y value going to be? -5? Sure. It could be anything. It doesn't matter. Okay, anything that you want. So here we go. I'm going to graph these 2, 2, 2, 0, 2, -5. I was thinking 2, 7. I had 7 on my brain for some reason. When I connect these dots, what's this kind of line that goes straight up and down? What is this called? Yes. So again, just like the previous problem, I would encourage you just to remember this to make your life a little easier. We're going to talk about horizontal and vertical lines again in the next section. Anytime you see x equal to a number when you're missing the y variable, it is just going to be a nice, beautiful vertical line. So last problem for section 2.1. On that graph or another graph, we've got plenty of graph paper. I'd like you to please graph x is equal to -8. All right, so once again, after you've done a few of these, you notice, oh, that has no y variable. So I'm just going to go back to -8, and I'm going to do a nice, lovely vertical line right here. You can plot points if you need to. That will always work. Oh, that was inconvenient that the pen ran out of ink at just that moment. Didn't run out. It's just a Dollar Tree pen. Oh, no, it did run out. Sorry, I didn't mean to accuse you of being a Dollar Tree pen. There we go. Better, better. And there's my line. And that is it for our introduction to graphing lines.